Okay, this is a lecture PPT slide for week 2. Yeah, this week we deleted the keyword of privacy, healthcare, blockchain, and the Internet of Things. So, title is a decentralized privacy preserving healthcare blockchain for IoT system. Okay. Let's begin with the abstract of this paper. Okay. Medical care has become one of the most indispensable part of human lives, leading to a dramatic increase in medical big data. You can see the Google data center. Google data center maintains a very, very big size of database. Especially YouTube video covers all part of our lives. Education area, music, orchestra playing, and even painters, the famous painting. They keeps lots of data. Okay. Medical area is same. Medical care produce a very big size of data. Okay. To streamline the diagnosis treatment process, the healthcare professionals, doctors, now adopting Internet of Things based wearable technology. Okay. Recent years, billions of sensors, devices, vehicles begin to be connected through Internet. One such technology is remote patient monitoring. We call RPM. RPM is common nowadays for the treatment and the care of a patient remotely. However, these technologies also confront with the privacy and the security issues. During data transfer and at the period of login of data transactions. Also, security privacy problems of medical data could result from a delay in treatment process. This is a latency issue. Long latency in the treatment process endanger the patient's life. In this paper, they propose the use of blockchain to provide secure management analysis of healthcare big data. However, the use of blockchain is expensive. Blockchains are computationally expensive. The reason is blockchain demands high bandwidth, demand lots of network resources, and extra computational power. And the blockchains are therefore not completely suitable for most resource-constrained IoT device. IoT devices usually have a limited network bandwidth, network resources, and IoT device usually have a limited computational power. Okay. So in this paper, they try to resolve the use of blockchain with IoT device. They propose modified blockchain model suitable for IoT device that rely on their distributed nature and other additional privacy security properties of network. These additional privacy security properties are based on advanced cryptographic primitives. They argue their solution make IoT application data transaction more secure and anonymous over blockchain-based network. Let's move to introduction. Many countries are suffering from a dramatic increase in the number of medical patients. It is getting more difficult for patient to access doctors or caregivers. In recent years, the rise of IoT and the wearable device has improved patient quality of care by remote patient monitoring. The remote patient monitoring system allows medical doctors to treat more patients. The remote patient monitoring RPM provide monitoring and care of patients outside of conventional hospitals, homes, where the clinical setting is ready. Okay. The RPM, remote patient monitoring, allows patients an intrinsic convenience of service. Even they are stayed far from hospital. Patients can stay connected with the health providers as required. Then the RPM system enables to reduce medical cost, improve quality of care. This is main reason that healthcare providers are exploring means by which to provide RPM to lots of peoples. Here, we can see the main component of remote patient monitoring system. The remote patient monitoring system is used to monitor and transmit health data to smart contract or smartphone with the internet connectivity. And RPM application. So the wearable device, IoT, plays important role in RPM in the current push to develop smart cities. Wearable device collect patient health data. Okay. Wearable device collect patient health data and transfer the health data to hospitals or medical institutions to facilitate health monitoring, disease diagnosis, and treatment. In doing so, we can see a big data situation develop through all the patient data being analyzed and transferred. Okay, this figure explains remote patient monitoring. Here is patient monitored in home. And the wearable device monitor the health data and transfer the health data to here certain RPM application or institutions, health providers can receive health data with their smartphones. Okay. Intermediate phase. Okay. There is a blockchain networks. Then health service provider can react to alert or interact with the patient. Okay. This way. So, okay. So we can focus on this system. Okay. Okay. Wearable device in healthcare are smart electronic device with microcontrollers that can be embedded into clothing, or the device can be worn on the body as accessories. So you can see this can be healthcare, this can be smart electronic device. Okay. So this device functions as wireless data transmission, real-time feedback, and alerting. Yeah. Those functions can be built into the smart device, electronic device. So this device can provide important information to healthcare providers, such as blood pressure, blood glucose level, breathing patterns. Okay. So healthcare device can be categorized into 4 types as follows. Okay. Here there are 4 different type of device. Okay. First, stationary device. Okay. Stationary medical device. This is not mobile. Here is here stationary medical device. Okay. So it's used on fixed physical location. Yeah. This is a station for home-based healthcare. Also, there is a medical embedded device here. Medical embedded device. This medical embedded device can be implemented inside the body. For example, pacemaker. Also, there is a medical wearable device. This is wearable device. This medical wearable device is defined as a prescribed device by doctors. For example, insulin pump. Also, wearable health monitoring device. This is health monitoring device. This is consumer product. For example, Fitbit, Pure Bands. Yeah. There is interesting drug. It's pill. On November 2017, FDA, Food and Drug Administration, approved the first pill with a sensor inside of it. Okay. The patient can swallow it. Yeah. So when a patient swallow it, the pill sensor send messages to wearable patch. Then the patch itself transmit the message to mobile application on smartphones. This technology could be a game changer for chronic disease and mental health disorders. Also, one of the Internet of Things device is the network wearable device. Network of wearable device. embedded with the software, electronics, sensors, actuators, and the connectivity, which enables the wearable device to connect, exchange data. In the future, the smart city we will not only see these wearable devices transmitting health data, but also it is reasonable to assume that the wearable device can share a myriad of data as we interconnect these devices. The reach of ideas presented in this paper regarding wearable healthcare device using blockchain technology are further reaching than is beyond our imagination. To handle such patient data with the other institutions, such infrastructure demands secure data sharing. Health data is highly private. Sharing of data may raise the risk of exposure. Okay. Furthermore, existing system of data sharing use a centralized architecture which requires centralized trust, like a financial system. In finance system, there is a centralized bank. Okay. Figure 3 shows the wearable device for patient. So here heart rate monitor device can check the heart rate. Pulse oximeter, sensors. This sensor can monitor the degree or the material. Also, accelerometer. Accelerometer can check how fast he moves. Okay. The solution of data privacy and security could and should very well be with the blockchain technology. Yeah. As you know well, the Satoshi Nakamoto proposed the Bitcoin, which uses blockchain technology. The blockchain technology provides robustness against failure and data exposure. Blockchain is a shared data structure. This is distributed database responsible for storing all transactional history. Okay. Ever transactions from the Genesis block. Block contains about 200 transactions. Blocks related to each other in the form of a chain. This is the reason why we call blockchain. The first block of the chain is known as Genesis. We call this Genesis block. Each block consists of a block header and the transaction counter and the transaction part. You see in this figure, okay, this is block. Block header part consists of header part and the body part. Body contains several transactions. Here, transaction 1, 2, 3, 4, n. This block contains n transactions. So the blockchain, it acts as a decentralized architecture to record data. The structure of blockchain is summarized in table 1. You see. Okay. Okay, here first magic number. This is 4 byte. Block size indicate block size 4 byte. Header total byte 80 byte. This okay, this header part. Total 80 byte contains version, here version, previous block hash. Each block has this block hash value. Pre-block, okay. This is this one. Okay. This is a previous block hash. Okay, this is previous block hash. This one. Yeah. Indicated this previous. This is n block, n minus 1's block. Okay, and the Merkle root. This is Merkle root. This is can calculate this input of the hash function is all the transactions in the body of the block. So output of the hash function is this Merkle root. This one. Okay, Merkle root. This is okay, Merkle root. Yeah. This is 32 byte. Also, there is a timestamp. This is 4 byte. Timestamp is here. Yeah. And the difficulty target. This is 4 byte. This difficulty target adjusts the average time for the mining process to succeed. Okay. Also, in the header, there is nonce value. This is 4 byte. Okay. Rest of a blockchain contains transaction counter. How many transactions in the body of the block, and the transaction list. Usually, okay, this is transaction list. Okay, up to 1 megabyte. Okay. Okay, let's see how transaction propagate to all blockchain nodes. Okay. For example, here is a transaction from Bob to truth. Yeah. 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 Transaction. Yeah. It's a transaction from Bob to truth. So this transaction input contains the private key of Bob. Okay, the signature is encrypted message digest with the private key of Bob. And this part, public key part, contains public key of Bob. Also, the TX out, this part is, okay, this is TX out. This part indicates the truth's address. So Bob create this transaction. So once here, once Bob generate this transaction, Bob sent this transaction to adjacent node. Okay. Here, adjacent transaction to adjacent node. When this node receive this transaction, okay, first check the validity of this transaction. So using this key, okay, this key, the public key of Bob, check this signature. Yeah. Once this check is valid, so that it means the signature is, if this signature is Bob's signature, okay, then this node keeps this transaction and sent to other nodes. Okay. When this node receives this transaction and the same steps, validity check occurs, and if this transaction is valid, then also send this transaction to adjacent nodes. Also here, this transaction, this node also keeps TX P Bob to T through this transaction. Keep this on. This also keeps. This keeps. So finally, like this way, all the nodes can keep this transaction. Also, then other nodes can also send another transaction, and then all the nodes maintain the transactions. TX2 is this one. Maintain a list of transactions. All the node maintains. Okay. All the nodes accumulate new transactions, and once the number of transactions comes to about 200, the mining node start to do the mining process. That is proof of work. Okay. So there are two kinds of nodes, two types of nodes, mining node and normal nodes. Okay. Mining nodes has capability to do the proof of work. So mining node can create block, but normal nodes only maintain this list of transactions. Normal node cannot do the proof of work. Okay, no capability of mining. Okay. Once the mining nodes stores about 200 transactions, it competitively involves to mining process. So the mining process is block creation job. Also, this block creation job is proof of work. Proof of work. This figure shows proof of work. Okay. Once mining nodes store about 200 transactions, then it start to create this block. First, this old transaction is input to hash function, and the output is this local hash value. This is block header, local hash. Also, this is previous hash value. This is a version. This is nonce. This is difficult to target. This is timestamp. Okay. Then for this header values, it use hash 256. Input is this block header. And try to hash this header value. Then output of hash function. This is message digest. This message digest check if this message digest is below, then this difficult target. Its hash value is less than difficult target, then block hash value is created. This is a success of proof of work, block creation. Block hash value is this output, message digest of this hash function. If the message digest is larger than this difficult target value, then it repeats the hash function once again. Then the nonce value, this nonce value increase by 1. And hash 256 function output message digest again. And check again. This hash value is, if this hash value is larger than, smaller than this difficult target value. If not, and this repeat again. So this repeat many times. So once the, okay, this is one hash. Okay, one hash. One hash is the means this one time hash trial. Okay. Once the message digest value satisfy the difficult target is within the range of difficult target level, then block hash is created. Then succeed to create block, succeed to mining. Okay. So block is then block is created. Okay, once a certain node succeed to create a block, okay, for example, let's assume this node succeed to create a block, and then this propagate sent this new block to adjacent node. Once this node receive new block and okay, then extend the current blockchain. So this new block extend this new block to existing blockchain, and then also send to this new block to other node. So every nodes maintain this extended blockchain. Okay. Now let's continue. Block blockchain security is based on the proof of work concept. A transaction is only considered valid once the system obtains proof of work. That means proof of work, enough computation work has exerted by authorizing nodes. So the mining node is responsible for creating block, constantly trying to solve cryptographic puzzles. This is proof of work in the form of hash computation. In the previous slide, we have already explained the form of hash computation. So this process, adding new block to blockchain, is mining. Each block in the chain is identified by a hash in the header. The hash is unique, generated by secure hash algorithm SHA-256. SHA takes any size plain text and calculate a fixed size 256-bit cryptographic hash. Also, each header contains the address of a previous block in the chain. So the inability to delete or change information from the block makes the blockchain the best appropriate technology for healthcare system. However, adopting blockchain in the context of IoT is not straightforward. It accompanies several problems, such as demand high computation power to solve POW. This POW is a problem. Low scalability and long latency for transaction confirmation over the blockchain network. This paper proposes the model of blockchain and eliminate the concept of POW to make it suitable for IoT device. The model in this paper rely on distributed nature and other additional security properties to the network. Transactions in the blockchain are broadcasted publicly in the blockchain networks and contain additional information about both sender and recipient. So Bitcoin use public address and the Bitcoin anyone can see what funds they already have stored at that address. This way, users cannot be anonymous in the network. Okay. But this is not correct. Okay. Because this public address, we cannot guess who have this public address. Okay. The owner of this public address. We don't know. Anyway, for anonymity and the authenticity of a user, this paper presents a lightweight privacy-preserving ring signature scheme that is suitable for anonymous transactions by authentic users. On the one hand, a lightweight digital signature guarantees that information has not been modified, as if it were protected by tamper-proof seal that is broken if contents were altered. On the other hand, ring signature allows a signer to sign a message anonymously. The signature is mixed with other groups, and no one knows which member signed the message. Okay. This paper does not use heavy computation such as pairing exponential in ring signature to make it more suitable for blockchain and IoT. This paper used double encryption of data using lightweight encryption algorithm, ARX ciphers, and the public encryption scheme. Here, double encryption scheme means this paper first encrypt the data using symmetrical key encryption and then encrypt the symmetrical key itself using public key. They are not encrypting the same data twice with different keys. Also, ARX cipher is a class of cryptographic algorithms which use three simple arithmetic operations, named modulo addition, rotation, bitwise rotation, exclusive OR. Simple computation operation. So ARX cipher has gained a lot of interested attention in last few years. For security in exchanging cryptographic keys over public channel, they use Diffie-Hellman key exchange technique. Using both these techniques together, ARX cipher and Diffie-Hellman key exchange guarantee security, privacy, anonymity of user data using lightweight technique suitable for small IoT device. Okay, until here I presented the paper. From now, you are responsible for summarize each part and present third week in the third week class. 아들 아재구마. Okay. Is responsible for this chapter 3 of this paper. Nobody sing. You are responsible for chapter 4. Ronel is responsible for chapter 5. Okay. Prepare assigned chapter and prepare summarized PPT slides and present each slide on Wednesday of third week. Okay. Thank you.